Welcome, learner. When you look at a perfectly formatted spreadsheet or like a beautifully colorful dashboard, there is this illusion of absolute order.
Right, it looks pristine.
Exactly. It feels like a smoothly paved road where everything just aligns. But if you actually dig under that paved road, you find this incredibly messy, tangled web of pipes and wires just barely holding the whole thing together.
Oh, absolutely. It's organized chaos.
Yeah. So today's exploration into the source material takes us right into that messy underground. We have a recording of a live one-on-one online data analytics class.
Yeah, it's a session between a student named Sugunu Moru and his instructor.
Right. And it is the very raw look at what wrangling data actually entails.
It really is. It's this fantastic snapshot
Yeah.
of a real-time struggle with Excel and then an introduction to Power BI. The whole goal is to distill the absolute best, most practical nuggets of data manipulation from this session.
Yeah, our mission for you today is to pull out those real-world techniques. Everything from advanced counting tricks to, well, the architecture of automated data pipelines.
And we get to do all that while completely bypassing the network lags, the buffering, and all those audio glitches of actual online learning.
Thank goodness. Okay, let's unpack this. Every data project starts with a really simple question, right? What do we actually have?
Yes, taking inventory.
But when Sagun tries to take inventory and count the regions in his data set, basic formulas like SUM and count just completely fail.
Right, because if you just run a standard count function on messy real-world data, you just get the total number of rows.
Which isn't what he wants.
Not at all. The data includes regions like Lagos, Calabar, and Abuja, but those names repeat multiple times down the column. So you aren't getting the actual number of distinct regions. You're literally just counting how many times any region was typed out.
It's like having a jar of jelly beans. Sagun was essentially asking Excel how many jelly beans are in the jar.
Right.
But what he actually needed to know was how many flavors of jelly beans are in the jar. He needed to isolate the unique items.
Exactly. And the instructor guides him to nest formulas to solve this.
Right.
You use the unique function to extract just the distinct region names, and then you wrap that inside a kata function.
And count cells that aren't empty?
Yes, exactly. So that combo gives you the final accurate number, but then the instructor throws a massive curveball.
Ooh.
Yeah, he shows Sagan an entirely different, highly mathematical way to get that exact same answer. It's sum products dt, and then in parentheses 1 divided by countif range.
Wait, really? That sounds like an alien language.
It looks like one too. But it's this brilliant trick that basically fractionizes the duplicates.
Fractionizes? How does that work?
Well, think about the mechanics. If the region Lagos appears 3 times in the list, countif assigns it a value of 3.
Okay, I'm with you.
By putting a 1 over it, making it a fraction, 13 Excel basically calculates 13 plus 13 plus 13.
Oh, wow.
Yeah, it mathematically forces those 3 duplicates to equal exactly 1 before adding everything else up. So it ultimately arrives at the correct answer of 3 unique regions.
Okay, I see the cleverness there. That's really cool. But I have to push back a little.
Sure.
If the counta with unique method is so straightforward and logical, why on earth would anyone subject themselves to that mind-bending sum products fraction math?
What's fascinating here is that relying on just one modern function limits your understanding of how Excel's underlying logic engine actually processes data arrays.
Ah, so it's about the fundamentals.
Exactly. The instructor insists Sagun write these older, complex formulas out by hand to build muscle memory. There is rarely just one way to solve a problem in Excel.
Right.
And you have to practice the hard way so the mechanical concepts actually stick in your brain.
That makes sense. So once you finally know exactly how many unique flavors of jelly beans you have, the natural next step for any analyst is to figure out which flavor is performing the best.
You have to move from simply taking inventory to applying conditional logic.
Yeah, and the assignment asks Sagun to find the minimum views specifically for men, and then the total impressions specifically for Logos and Calabar.
The instructor introduces the IFS family to handle this. So you've got MINIFS, MAXIFS, and SUMIFs.
And the distinction there is just about the number of rules.
Purely based on the number of rules.
Right.
You use SUMIF singular when you only have one criteria to check.
Right.
But if you have multiple conditions that need to be met simultaneously, you must use SUMIFs plural.
And this is where the strict grammar of Excel rears its ugly head. Sagun actually hits an error because he didn't wrap the word men in double quotes.
Yes, the software is completely blind to text strings unless you use those quotes to identify them.
It's so picky. And then for finding the total impressions for both Legos and Calabar, Segun basically just brute forces it.
He really does.
He writes a full SUMIFs formula for Legos, literally types a plus sign, and then writes a whole second SUMIFs formula for Calabar.
I mean, hey, he gets the job done for 2 cities.
It does, but here's where it gets really interesting. If we are just chaining SUMIFs together with plus signs, isn't there a breaking point where doing this manually just completely collapses?
Oh, absolutely.
I mean, what if you have 50 regions?
That breaking point is exactly why the instructor eventually introduces the concept of pivot tables.
Ah, okay.
Because to find the single region with the most impressions, using basic formulas, Segun would first have to generate a list of all the unique regions.
Right, step 1.
Then he would have to manually calculate the total impressions for every single one of those regions individually.
That sounds awful.
And then he'd have to write another formula to extract the maximum value from that new secondary list. It's a highly complex, multi-step trap.
Yeah, it sounds like trying to build a house using a Swiss Army knife. You could technically chop down a tree with a tiny blade by endlessly chaining manual formulas together.
But eventually, you need a different tool entirely.
Exactly. You need power tools.
And instead of writing 50 different manual formulas for 50 cities, a pivot table lets you literally drag the city column into a box.
It's so much easier.
Yeah, the software automatically groups, summarizes, and calculates the totals in the background. The instructor saves the actual training for a future lesson, but introduces pivot tables as this elegant, purpose-built escape hatch from manual formula nightmares.
They really are the power tools. And if pivot tables are the power tools of data, the natural progression is to stop building things one by one and just construct an automated data factory.
Right into ETL.
Yeah, the class naturally moves from manual Excel manipulation into the world of Power Query and Power BI to learn ETL.
Extract, transform, and load.
Break that down a bit.
So the instructor breaks down the mechanics. You extract data from a source. You transform it, meaning you clean it up and shape it using Power Query.
Right.
And then you load it into a page or dashboard to visualize it. He also introduces data modeling.
Oh, the primary and foreign keys?
Exactly. This idea of joining different spreadsheets together using those keys, it's essentially like giving every piece of data a unique ID badge.
So they can talk to each other.
Yeah, so a sales spreadsheet can automatically talk to a customer spreadsheet without you having to manually copy and paste between them.
It's brilliant. It allows you to set up pipelines for continuous automatic data refreshes.
Yeah.
You set it up once, and the data just flows.
Yep.
But if you're sitting there right now using a Mac to try and upskill, you might hit the exact same roadblock Segun hits here.
Oh, the hardware issue.
Yeah. He tells the instructor he literally cannot find Power BI in his App Store.
Right, because Power BI Desktop is heavily tied to the Windows ecosystem.
Which is so frustrating for Mac users.
It is. The instructor offers a few workarounds, like partition the Mac to run Windows, or use the web version of Power BI.
But there's a catch with the web version, right?
A strict catch. It requires a registered organizational or enterprise email account.
So what does this all mean? Are you just entirely locked out of this Power BI revolution if you don't have a corporate email address?
If we connect this to the bigger picture, specific hardware and software ecosystems definitely have distinct walled gardens. Power BI on a Mac is inherently tricky.
Yeah.
However, the underlying logic, the concepts of extract, transform, load, and data modeling, through those unique ID badges, that is a universal language.
Oh, I see.
Yeah, understanding how data flows through a pipeline is a mechanism that transfers across any operating system, whether you eventually apply that logic in Power BI, Tableau, or even advanced Python scripts.
That's a really great point. Looking at this whole journey, we started with Segun fighting against basic counting formulas, trying to understand the flavors of jelly beans.
Right.
Then we moved into the strict grammar of conditional logic, and finally hit the absolute limits of manual formula typing.
Realizing that to scale, you need automation.
Exactly. You need automated ETL pipelines to do the heavy lifting for you. And through it all, the instructor's core advice remained constant. Whether you use AI to look up the formula or figure it out yourself, actually putting your hands on the keyboard and practicing the repetition is the only way this knowledge sticks.
Which brings up a really interesting transition point in a data career. If tools like Power Query and Power BI can completely automate that extract, transform, and load process with scheduled automatic refreshes, at what point does a data analyst stop being a number cruncher and start becoming a pipeline architect?
Wow, yeah.
Like, what happens to our deep foundational understanding of the data when we no longer have to manually touch the formulas at all?